Marine renewable energy is helping the UK to reach net zero. However, to support the growth of this energy source utilization, the industry must expand their development levels by about 100 times in the next few years. How can the tidal array detail help solve this problem? The product is developed to support stakeholders, providing them with forecasting insight and allow simulation of what-if scenarios to design and monitor the operation of the turbine arrays. As such, it has multiple capabilities from resource assessment to array design and performance evaluation. The product is accessible via Iliad Marketplace within the Twins Lab ecosystem. When using the digital twin, we can address some typical requirements from governmental agencies and decision makers. On resource characterization, how much energy is available at the prospective sites at any particular time? On design, how do we best configure the layout of individual turbine specifications? On operation, how would an array of a given size and device type perform? Why do my turbines generate a particular amount of power? Or how much power can I expect to deliver today? On impact assessment, how do we change the turbine array surrounding environment? To address these requirements, we offer a comprehensive multiscale system, meaning a wide range in size from tens of kilometers at regional scale to just meters to represent individual turbines. The integrated solution also includes data acquisition, analysis, and computing. This would help us avoid shortcomings from setting up separate systems to deal with each request. At the core of the Tidal Array DTO is the Thetis hydrodynamic solver, which is based on the Phydrake finite element modeling framework. The model uses an unstructured grid and demonstrates the tidal turbine array deployed in the inner south of Scotland. Multiple data sources have been used. Seabed elevation data, tidal gauge data provided by BODC in the form of time series for model calibration, ADCP data on tidal velocity flow current, which is collected by MeyGen Ltd, our prospective client, also provided a turbine power datasets for model validation. No citizen science has been involved in this pilot so far because the site is highly dynamic, inaccessible condition to the public. Let's visit AquaSafe, the website that hosts the tidal array pilot. After login, you have access to an intuitive web interface. On the Orkney mesh panel, you can display the computational grid and manipulate to examine the multiscale nature of the problem. Switching to the hydrodynamic panel, on the left, you can visualize tidal dynamics by displaying and comparing water levels and flow velocity at certain gauge locations shown on the right. Switching to the main panel, you can see how strong are the tidal currents at the turbine locations, as well as how much power can these turbines generate. All this information is extracted from modeling output. The DTO can have major impact on the society and particularly remote communities that have access to the resource. With this pilot, we engaged with the tidal energy industry and also the government regarding sustainable development, renewable energy, and environment. In particular, cooperation with the Crown Estate Scotland supports consenting and leasing processes as well as navigating interactions between the ocean space users. Our stakeholders include decision makers and the marine energy developers. Collaboration with third parties helps us identify new uses for these DTO services, offering specialized solutions normally inaccessible in-house by clients. To recap, the DTO is unique because it is based on multiscale models which relate to many applications. We deliver a web-based software tool to monitor the real-time power output of the tidal stream turbine array deployed. We showed capabilities in modeling the ocean processes for both validation and operational use. The capability of performing fast, reliable simulation makes the product suitable for real-time operational purposes. The system links expertise from several disciplines. That is challenging to combine. Development for the functionality testing is important to ensure that the users will obtain accurate results continuously in accessible format. When clients provide specific data streams, this data needs to be quality controlled and integrated in the system. For interoperability, we want the features to be used for other applications aside from this tidal energy pilot. This opens up the opportunity to exchange data and computational modules between the components.